Hello Intro Chem friends, welcome back. In this video we're going to talk about how to use the solubility rules and our knowledge about chemical reactions to answer this question. When we have aqueous solutions of potassium iodide and lead 2 nitrate, will we form a precipitate? Will we form a solid? So basically this question, there is asking us if a double displacement precipitation reaction will occur. So to determine if a reaction occurs, we need to see what the products are, what is produced when mixing aqueous solutions of potassium iodide and lead 2 nitrate. So I have that shown here as a cartoon. So I know that since I have aqueous solutions of these two ionic compounds, that what is actually swimming around in solution are the ions potassium iodide and lead and nitrate. So when I mix these two together, those are the ions that are actually swimming around in my beaker or my flask. So to determine the products of this potential reaction, what I need to do is take the cation from one compound and pair it with the anion from the other compound. So that's written down here, but I think it's really instructive when predicting these precipitation reactions or double displacement reactions, to write down in this little crisscross method what ions are present and then be able to correctly pair the correct cation with the correct anion. And I'm going to use a little crisscross method very similar to what we did when putting ions together to form a neutral molecule in chapter 5. So let's go ahead and get started. So in this first little area here, I'm going to put the cation from my first species, which is potassium. I'm going to put the actual element and its charge. Potassium is a +1 charge. What is the anion that is with that potassium? Well, it's iodide, which has a -1 charge, or -1. So I have the cation and the anion from my first species, the potassium iodide. Now we're going to do something similar with my second compound, the lead 2 nitrate. What is the cation from that second compound? Well, it's lead, Pb, and the charge on that lead is a +2. Now, how did I know lead was a +2? Because if you remember from chapter 5, lead can sometimes be +2 or +4. How did I know, how did I know it was a +2? Well, I need to look at my formula and remember that the charge on NO3, which is the anion it's attached to, is a -1. It's from the list of polyatomics from chapter 5. There's 2 of them there, right? In this balanced formula. So the charge on that part of the molecule is a -2. And so for the charge on the entire molecule to equal 0, because remember the charge on ionic compound overall has to be neutral, has to be 0, that means my lead, to counteract that -2 charge, must be a +2. So that's where my +2 came from with the lead. I had to look and see what that lead was attached to and what its charge was to determine the charge on the lead. So if you need to review how we put ions together to form neutral molecules, that is from chapter 5. But lead is a +2. That is the cation of my second species. The anion of my second species is that polyatomic NO3, that nitrate that has a -1 charge. So I have now written the cation and the anion for both of my species, with the first species on top, second species on the bottom, and now I can do my crisscross. I can do the cation of one species pairing with the anion of the other. So that means my potassium is going to go to the NO3, and my lead +2 is going to go with the iodide. So when I write my predicted products, I can see that, oh, I'm going to have K go with the NO3, and for every +1, because potassium is +1, I have an NO3 that's a -1. So KNO3. That lead is going to go with the iodide. So I'm going to have Pb. That Pb is a +2, right? We determined that previously. And that iodide is a -1. So I'm going to need 2 of those iodides when writing my balanced formula. And that 2 is going to be a subscript. Remember, always subscripts when writing balanced chemical formulas. Coefficients when balancing chemical equations. So those are my 2 products from this reaction between potassium iodide and lead 2 nitrate, the cation from one species paired with the anion from the other species. So I really think it's instructive to do this little crisscross like I've shown here. They've sort of shown it here in your textbook, but I kind of like when I write it, you actually show the charge of the molecule. So you get KNO3 and PbI2 as your products. So we're getting close to answering the question, do we form a precipitate when mixing potassium iodide and lead 2 nitrate? Well, we need to take what our 2 products are and look to see what their solubility is. So I see that under nitrates that there are no exceptions, so all we're under the soluble section, so all nitrates are soluble, and things that are soluble are going to be aqueous. And I see iodide is also under the mostly soluble, but there's the exception of lead. So that lead 2 iodide is insoluble. It's going to be a solid. So is a precipitate going to form when we mix potassium iodide aqueous and lead 2 nitrate aqueous? Yes. That solid will be PbI2. So if I was to write that as a chemical equation, this is what I would write here with the states. So that's something that you should be able to do using these skills. You should also be able to look at that and say, that's a chemical equation, but is it balanced? Does number and type of atom on the reactant side equal number and type of atom on the product side? And hopefully you can say, no, it doesn't. I have 1 potassium here, 1 potassium here. I have 1 iodide here, and I have 2 iodides here. So the only way I can get 2 iodides on the left here is to put a 2 in front of that potassium, is to put a 2 in front of the Ki. So I now have 2 iodides, but I also have 2 potassiums. That's okay, I can fix that by putting a 2 in front of the KNO3. And that works out great because I now have 2 NO3s. And how many NO3s do I have on my reactant side? I have 2 NO3s. So I now have a balanced chemical equation that is a precipitation reaction. I know it's a precipitation reaction because I have formed a solid. I determined that from the solubility rules. I also I was able to predict those products by doing a double displacement reaction where the cation of one species pairs with the anion of the other. So in the next video, we're going to do 2 more examples. Now that video, I filmed it, or I recorded it in the spring semester, so you'll hear me say, welcome to my very first chapter 7 video. That is from the spring, okay? We're going to go over 2 more examples of double displacement precipitation reactions and proceed on with talking about the other types of chemical reactions that you need to be able to classify and identify in this chapter.